Hello everyone, welcome to my channel Let's Understand. I am Amal and a software engineer. Let's understand our today topic, computer and software. Before going forward, I want to discuss one thing. In my previous video, we already explored relation between computer and programming language. If you not watched that video, computer and programming language yet, please go and watch. You will get definitely some clarity from there. Today's video is continuous of our previous video. So without any delay, let's understand our today's topic, computer and software. We already discussed computer system in our previous video that computer is nothing but a set of hardware, and for making that hardware in action we require software. So computer system is the combination of hardware and software. We also discussed in our previous video how the things is managed of computer system, just like for input devices keyboard is required, for or joystick anything, and for output monitor printers, for computational there is a CPU, for runtime storage there is a primary storage RAM, and for permanent storage we called the hard disk, so disk and tape. The permanent storage also called auxiliary storage devices, secondary devices. So now come to our main topic, software. Software categorized in basic two types of software. One is the system software, one is the application software. System software is the things who directly communicate with the hardware, and application software is that this run over the application software, system softwares. So if you take example for system software, operating system, that is Windows, Linux, Mac. This is the operating system. They directly communicate with the hardware, just like CPU, RAM, all the things. And for application software, we can say that Office, Outlook, Gmails, this is the application software. And for further we divided in their different type of software: operating system, system support, system development, general purpose, specific applications. So come to our next topic, next understanding how that hardware's operating system, software, that means application software, and user is connected. Suppose that you are the user, you go to the laptop or computers, how the things is look like. You see the output device, the output screen, that is the screen. This is the, if you work on the computer there is a monitor, if you work on the laptop there is a screen. So this is the output screen where user interact with, so either input device, keyboard or mouse. So the keyboard or mouse interact with application softwares, and that application softwares run on the system software, that is called operating system, and that operating system directly communicate with the hardware, that is the RAM, CPU, all the things. So the whole structure is divided like this. Like suppose that you are the user and you want to send a mail. Suppose that to take basic example, you want to write something on the notepad. So in notepad you open the notepad, either keyboard or mouse. So user interact with the computer with help of input device, mouse, and you hit on the icon button of the notepad. So operating system open that notepad, and notepad is called the application software, and that application software is run over the operating system. And now you write something like hello, let's understand operating system and let's understand softwares in our notepad, and that you save that. Or for saving the things in the permanent storage, operating system take a place and save the notepad text file in permanent storage. This whole things behave like this. So now understand our time sharing environment. There is a multiple terminal connected with the central computer. This is our basic CPU where multiple shared printers or output devices connected, and this is the central storage. So this is basic structure of time sharing environment. So now come to the another picture, that is called client server environment. So there is a one particular server and multiple client is connected with that server, and this is the central storage and this is the shared printer. This is the basic structure you will see in cafe. The cafe use this type of server. They connected multiple terminals in particular servers, and that server have the internet facilities, and that server also connected with the printers. You go in your terminals, do your uses, or you want to print something, you access the internet from the server, and hit the command print, and server send the command to the printer that this file need to be printed, you take. So this is the basic structure of the client server environment. So now come the distributed computing. This is the same. So here suppose that the server is not here, and you connected with the browser. That previous example is for a specific office, but if the server is not available in the office, that means it is the outside, that is connected on the internet. Suppose that you are watching the YouTube video. This is the your terminal, and YouTube is a store. YouTube data is stored in particular servers. So for accessing this YouTube data, you click open the YouTube application, and YouTube is a application software. You open that URL in your machine. That URL communicate to the server with help of this internet, and you will get the data. Now come to the computer language. We already discussed in our previous videos that for communicating with the hardware, we need a software, and for making the software we need programming language. So to write a program for a computer, we must use a computer language. Over the years, computer language have evolved from machine language to natural language, and that means high level language. This also we discussed in our previous video. So in this video, we discuss in more visualized form machine language, assembling language, and high level language. So when computer is in their starting phase, in 1940 there is machine language. Everyone go and write program just like for working computer 1010. In 1915, for making more flexibility to the programmer, it's they develop assembling language. And after 1960, for making more human readability and human friendly to write program in computers, they introduce high level language. So this is the basic structure of computer language evaluation. So this is the basic example of machine level language. So we already discussed in a previous video that for computer does not know anything except 1010. So this is the basic structure how computer know the low level language, that is the machine level language. So now this is the only language understood by computer hardware is machine language, which we discuss now. So this after the too much problem facing, they decided to introduce some assembly language, and this is this assembly language. If you study a microcontroller, in microcontroller you will also see how assembly programming language work there. So after some assembly programming language, the high level language comes. So this is the basic structure of the C, and now here you understand better in perspective of programming and human readability. If you see in previous slides, this is the basic machine language, pure machine language. For human readability, who does not context how what need to do, they got confused here. In assembly language, also more syntax and command need to be remember accurately to do programming. So in high level language there is nothing, this is the more friendly of human. So if you see there, this is the standard library which need to be used. After that, this is the basic structure of writing the program, and here you use the scanf function to take input. In C there is a multiple function, a scanf, cout is the for C++, a scanf and printf. So you take one input, you take second input here, you multiply both of the things, and here you print the result. So now here you understand basic how programming is written. Now come to the point, creating and running program. You create the program on C or C++ or Java, but how it's run over the CPU, or how it's converted, because we throughout the video we know that machine know only 1010. So there is a process to convert this program which you write in C or C++ or Java to the machine language. So in this section we explain procedure for turning a program written in C into machine language. The process is present in straightforward linear fashion, but you should recognize that these steps are repeated many times during the development, correct errors, and make environment of the code. So this is the basic that when you write the code, through the whole life cycle, you suppose that you need to write the multiplication of two numbers. So there is you first write the multiplication of two numbers for positive. So you need to correct also for negative numbers. So you take the negative input and do it. So if your program has some errors, you correct and in next iteration. This is the simple things he want to explain. So topic discussion in this section: writing the program, editing, compiling, linking, and executing. Compile, what is the compilation? I already explained in previous video. So come to the next. So this is the main C program which you written in your text editor or either any of the IDE. So this is your source code. after that you compiler take the place and convert this source code in the object format. And after the object format, the linker come in the picture. Linker is the things, just like if you go here, there is you use stdio.h. So this is the library which need to be support before convert your source code in the machine language or executable format. So this linker take the place and scan your source code, and which of the library need to be linked, they link that and convert your file in the executable format. And after taking the executable format, it's go to the runner, and runner run this program, and result will be published. So this executable format have the machine level language, so your computer understand better. So converting this source code which is written to C, that is high level language, to the machine level language, that this process is come in the place. So now come to the system development. We have now seen the step that we necessary to build a program. In this section, we discuss how we go about developing a program. The critical process determines the overall quality and success of our program. If we carefully design each program using good structured development technique, our program will be efficient, error-free, and easy to maintain. Suppose that you write a program for library management in C. So the whole structure come in the picture, that how you make the library management, what different type of step you take, and which design you take. So the system development life cycle come in the picture, and program development. So just after you just like we take the example for library management. So for library management, what you need to do? First, you need to understand the requirement, system requirement, what you need to do, how need to do. After taking the requirement, you do analysis. Actually, this needed, and if needed, how you can do better. And when your analysis is done, you take the design. That means design in the sense that how you are going to code, which thing need to be developed first. And after design discussion, you ready for the code. After your code is ready, you test your system, and if your system is good, well, you deploy, and after that you maintain the system. So this is the basic structure of system development, and that structure called waterfall model. So except for the most simple program, one set of test data will not completely validate a program. So we already noted here discusses system test. When you develop a system, you need to test that. And how you need to test that? By testing that. Suppose that you develop a system library management, and there is one book which is given to one of the student. So this is how you test that this is working fine or not. So for that you make one unit test, and that unit test is run over there, and if everything work fine, you can say the system is working fine. But in this line, it is clearly we understand that for making one particular unit test, it does not mandatory that your system is tested well. Maybe for another test cases your system will fail. So for some unit tests, it's not the mandatory. So this is our end of the video. So let's meet our next video where we can discuss more on this topic. Thank you. And if you like the video, please subscribe and share with your friends, and smash the like button. Thank you.